everyone, so today we will be looking into June OMB solution. So let's first read the question. So the question says, let triangle PQR be a right triangle with PQ equals to 90 and PR is equals to 120 and RQ which is equals to 150. And now if we draw an inscribed circle inside the triangle touching all the three sides, okay, this would be an inscribed circle and this is C1. Okay, now construct ST with S on PR, so we can S on PR and T on QR and T on QR such that ST is perpendicular to PR. ST, as you can see, is perpendicular to PR, 90 degree here, and tangent to C1, which means that it touches the triangle touches the side ST. And construct UV. So let's keep with U on PQ. So we have U here on PQ and V on QR and V on QR such that UV is perpendicular to PQ. So it also has to be tangent to the circle. So we can say, and it is perpendicular to PQ, which means it makes 90 degree with the side with this PQ. Now what the question is saying is, let C2 be the inscribed circle of RST. So let's draw inscribed circle here, and this is C2. And let's draw inscribed circle here and call it C3. So if C1, C2 and C3. And now it's saying that you calculate the distance between the centers of C2 and C3. So if this is the center, then we are asked to calculate this particular distance. So and it is written as root of 10n, and we have to first and we have to calculate for n. So what we can do with this is, so we can take hints from the length given here. So we're given 90, 120 and 150, and we're given a right triangle, right? So what we can do is we can place this whole triangle on a Cartesian or a coordinate plane. So let's say this is y, okay, y, let's say this is x, okay. Now let's keep P as our reference point, which means the coordinates of P is 0, 0. Now let's look at what Q will be. Q will be simply 90, 0, because we know that this length is 90. Now let's also find out the coordinate for point R here. So it's going to be 120, 0, 120. So 0 is the x coordinate and 120 is the y coordinate. Now let's also find for u here. So u is going to be simply, before we find for u, what we can do here is, we are given C1, right? And we can find the radius, the in radius of C1. Now the formula to calculate an in radius is a plus b minus c divided by 2. Now a plus b is the two legs of the triangle and c is the hypotenuse. So what we can do is, we can add 90 plus 120 and subtract it by 150 and divide it by 2. So we get 90 minus 30 divided by 2, which is 60 divided by 2, which is 30. So we get the in radius of C1 as 30. So which means that from here, this center of the circle, till this point, it is 30. So if it's 30 till here, and we have 30 more here. So if we add 30 plus 30, we get 60. So 60 is the x coordinate of point U with y coordinate 0. Now let's find the coordinates for the point S here. So we know this from here to here is 30, and from here to here is also 30, because the in radius is 30. So 30 plus 30 is 60. So we can write as it as 0, 60. So that's the coordinate of point S. Now what we can do here is, we can like draw out RST. So since they are similar triangles, we can see that angle S is perpendicular, as well as our angle P is also perpendicular, which means they both have a 90 degree, right? so they are similar triangles. So these three triangles that you see, they are similar triangles. So what we can do is we can compare triangle RST. So let's take it out. RST. Now what's the unit, what's the length of RS? So if it's 120 till here and if it's 60 till here, then we certainly have to subtract 120 minus 60, from which we will get it as 120 minus 60, so it's going to be simply 60 here. And we need to find the in radius of circle 2, right? Now we know the in radius of circle 1. So in radius of C1 is that of the whole triangle, where C2 is that of the triangle RST. Now we know that we can compare this 60 length to 120 length of the length PR, because they're similar triangles. So let's compare R2 by, so let's make it into a ratio because they're similar triangles. So R2 by RS will be, so RS means we have to take the length PR here, PR for the in radius R1. So in radius is of C1 is 30 and PR we know is 120, and R2 divided by RS is 60. So 61, 60, 62 is a, and we get R2 as 15. So R2 is the in radius of C2. Okay, now similarly we're going to use the same technique. So we're going to take out the small triangle now. Taking the small triangle V, U and Q. So what's the distance from, so if it's 60 till here and 90 till Q, then we simply have to subtract 60 from 90 and we get 30. So we can compare R3. We are trying to find the in radius of this circle, right? So that's going to be R3 by UQ, which is equals to UQ PQ of the bigger triangle PQ, and R1. R1 is the known value 30 divided by PQ is 90. So 3 ones are 3, 3 threes are 9, and we have R3 by UQ, which is equals to 30. So we know that 3 times are 30. So R3, when we cross multiply, we get it as 10. So we got the in radius of circle 3 as 10. Now what we are going to do is, we have found the in radius. Now we can use the in radius to find the center of the circles. So centers of the circles. So let's take out triangle RST here. Now we know that the center of the circle is, okay, so from point S, which is 0, 16, right, 60, right? So we just simply add the in radius 10. So we know that the x unit is 10, right? Now what about the, sorry, it is 15 actually. So it's going to be 15. And so we have to add 15 here. And as for the y coordinate, we have to add 15 to 60 degree, which is 75. So we get the center coordinate of triangle RST of the inscribed circle as 15, 75. Now let's take out this circle and this triangle and use U as the reference point, that is 60, 0. Now similarly it's going to be R3 units to the right and R3 units upwards. So we are going to, so the as for the x coordinate, we just simply have to add 10 to the 60 here, so the x coordinate becomes 70. And as for the y coordinate, it will stay the same, that is 10. So now we have got the two centers of the circle, right? So we just simply have to find the distance between these two centers. So we can calculate the distance by using the distance formula between two coordinates as y2 minus y1, y2 minus y1 whole squared plus x2 minus x1 whole squared, which is equals to, so we can take this is y2, which is 10 minus 75 whole squared plus x2 as 70 and x1 as 15 whole square. That's going to be equal to 10 minus is negative 65 whole squared plus 70 minus 15 whole squared is going to be 55, and we get the answer as 7250. But that's not a final answer, as we have to calculate for n. So we can say 10n is equals to root of 7250. So we can remove the root, as it is present in both the left side of the equation as well as the right side. So we can write this as 725 times 10. So 10 can cancel, and we get n as 725. So that's our answer, and I hope you understood the June OMB solution. Thank you.